me choose a color. Yes. So in the first class in kinetic theory of gases, so this is for those of you who missed it, very quick revision. I'm not going to spend lots of time on it. This is what we studied in the first class. What we studied was, first, we studied the postulates. So kinetic theory of gases gives us a very easy way of understanding why gases behave the way they behave, right? So there are some simple, although these postulates are not necessarily true, these are simplifications we use to make sure that we get a nice mathematical expression that agrees with the experimental results. In the last class also, many of you were asking, why, sir, how can we assume that a gas moves, basically has an elastic collision? Sir, how can we, all of you are correct. We cannot assume that, but despite these assumptions, the end mathematical formula that we get agrees with the experimental results. That's why we still believe that the kinetic theory of gases is a very simplified but yet very accurate description of gases. So there are multiple 5 to 6 postulates that we studied. I'm going to write it in quick short form. First thing was gases undergo random motion. Correct? That's the first thing. Second thing was gas molecules don't exert any force on each other. Don't exert force on each other. Third thing was gas molecules are very small compared to the distance. So the third thing was gas molecule size very small compared to distance. Between them, right? That's the third postulate. And the fourth thing was basically collision with wall are elastic and there is very little time between collisions. Right? So these were the main postulates. There were 1 or 2 more postulates that you can, if you go into your textbook, you will see that the main postulates were these, right? Now, based on this, the second thing that we studied was the speeds of gas, molecules. These were governed by Maxwell's distribution law. What Maxwell's distribution law says, very simply to understand, is that it is not every molecule in a gas has the same speed, but the number of molecules having a certain speed after some time at steady state becomes constant, right? So even though some molecules may be 10 meters per second, some molecules may be 20 meters per second, some may be 30 meters per second, but after some time, once you allow the gas to settle down, what will happen is, even though speeds will be different, the number of molecules with 10 meters per second, the number of molecules with 15, with 20, for every speed, the number of molecules having that speed becomes constant. And Maxwell described a complicated equation that you don't need to remember, but all that you needed to remember was it was a curve like this. This basically tells you the y-axis was number of molecules and the x-axis was speed. So this speed tells us how many molecules, so this is the number of molecules, are at what speed v. So if you want to find out at 10 meters per second what was the speed, all that you have to do is basically find out what is 10, and whatever is the number that corresponds in this curve that corresponds to 10, that basically tells you the number of molecules with 10 meters per second. So this was the second thing we studied, right? So this was a very quick recap of what we did in the first class, right? Details can be viewed on the first lecture that I will send to you at the end of this class. Now, in last class, what we studied was, we studied a very simplified way of finding the pressure due to a gas by using kinetic theory. So there was a very quick derivation that we did. It seemed very complicated, but now for those of you who attended my class, it will seem very simple. Let's now see what were the steps of that derivation. What the derivation states is that Because one postulate of kinetic theory of gases is that all gases obey Newton's laws of motion. We said that if you want to find out the pressure due to a gas, that's what we wanted to do. If you want to find out pressure, now we know the definition of pressure is force upon area. So if you compute, so we assume, the assumption we make is the gas is enclosed in a spherical box of length L. So this is what we assume. We assume that the gas molecules are contained in a spherical box of length L. Now we take one face of this. So let's, for instance, take this face, right? And there, obviously, inside this, there are going to be lots of molecules moving, hitting the wall, rebounding, right? So we are now going to take one wall and find out the pressure on one wall. So the pressure on one wall will be force on that wall divided by the area of that wall. Now, what is the area of a square wall? The area of a square wall is going to be F by L square. L square is going to be the area of the wall. All of you know this. Now, if L square is the area of the wall, L is already known to us. If I want to know pressure, I only need to find out F. Now, how do I find out F? F, from Newton's second law, we know that F is rate of change of momentum. Rate of change of momentum is delta P upon delta T. This was the first step we studied that day. So I'm just going to doing a quick recap. Okay. Now if you take a wall, what is the rate of change of momentum? What is happening? This wall is in the cube. The distance between the two walls is L. If you take one molecule, it will go with the speed of Vx, but because according to kinetic theory, the collisions are elastic, it will also come back with the speed of Vx. Now the time between two collisions, so once it collides here, it will go all the way like this, then come back. For the second collision to happen, it has to cover an extra distance of 2L, right? So which basically means the change in momentum, initially it was mvx, finally it is minus mvx. Sorry, this is plus mvx, this is minus mvx. So change in momentum is 2 mvx, mvx minus mvx. So the numerator is 2 mvx. And the time taken for the next collision is the distance covered 2L upon Vx. Distance upon speed is the time taken. That's a simple formula. So this turns out to be mvx square by L. This was step 1. Step 1 was to conclude that the force due to the x direction is mvx square by L. Now the second step, what we basically say is, because molecules undergo random motion, random means everything is possible, each thing is equally possible. So what we basically say is V is root of the x component of the velocity plus the y component of the velocity plus the z component of the velocity, correct? So V square is Vx square plus Vy square plus Vz square. Now because it is random, all three motions are equally likely. So we can say Vx is as likely as Vy and is as likely as Vz, right? All chances are the same. So we can assume, again this is not true, but we can assume that Vx is Vy is Vz. So we can say V square is 3Vx square. Why? Because random motion, this implies Vx has the same chance as Vy has the same chance as Vz. We can assume that. This is not true. Again, remember, don't get confused on how can sir say that Vx is Vy is Vz. This is a conclusion we use because of kinetic theory assumptions. Now, if V square is 1 by 3 Vx square, we can say that Vx square is V square by 3. Now, if I substitute this value of Vx square here, what I get is F is mv square upon 3L. I may not have done this in the last class, but this is something, we had something similar. I think we did by mv square by 2L. So this is what we get as the second step. The force is mv square by 3L. Now, I hope this is clear. The first step was force is mvx square by L. Second step was force is mv square by 3L, where v is the total velocity, the sum of the x, y, and z components. I'm just going to move down. The third step, a very important step. What we do in the third step is, now we say that if this is true, if F is mv square by 3L, I can make a small rearrangement into this. Pressure is force by area, which was force by L square. So pressure now becomes mv square by 3L divided by L square. So it's 1 by 3 into 1 by L cube into mv square. Correct? This is what we can say is pressure. Correct? Now, what we can rearrange this as 1 by 3. Now, L cube is the volume of a cube. So I can write 1 by 3 into 1 by V, because L cube is the volume, into mv square. Correct? Where V is the velocity. Now here, we are talking about only one molecule. Now if we want to talk about n molecules, what we do is, P is 1 by 3 into 1 by V. What I'll do is, numerator I'll multiply by the n molecules that are there in the box, and denominator I will divide by n. So the quantity still remains the same. Correct? Now this basically becomes 1 by 3V. Now, mass of one molecule into the total number of molecules is the total mass. So that becomes m. Sigma V square by n. If you remember, what we had studied was, this was the definition of V RMS square, right? This was the definition of the root mean square. Just like x1 plus x2 plus x3 plus xn upon n is the mean, regular mean. x1 square plus x2 square plus x3 square plus xn square upon n ka under root is defined as the RMS, root mean. Correct? So this is now root mean. So pressure basically becomes m by V into 1 by 3 into V RMS square. This is where we ended the last class. So this is the expression that all of you need to remember. So let me just do a quick recap.
Ashwin sir.
We basically saw first step, force is delta P by delta T, which becomes mvx square by L. Second step, we said that because all motions are equally likely, Vx is Vy is Vz, hence Vx square is V square by 3, because V square becomes 3Vx square. If we substitute that in the first expression, we get F is mv square by 3L. So F is mv square by 3L. Now, if I now substitute the value of F in the pressure expression, F by L square, I basically now get pressure F by L square, which is 1 by 3L cube mv square. Now I do a small change. I write L cube as V, because that's the volume of the cube in which all the molecules are present. And this mv square expression, I multiply and divide by n. Now mass of one molecule into n molecules is the total mass. So I write capital N. Now sigma V square by n is basically the root mean square ka definition. So root mean square is basically nothing but sum of the individual squares of the individual numbers divided by the total and basically do an under root. That gives you VRMS ka square. That's the definition of VRMS, which we studied in the previous class.
Hello, Ashwin sir.
At P is 1 by
Hello, Ashwin sir, can you hear?
M by V into VRMS square. This is where we stopped the last class. I see many of you now raising some doubts. Let me see. What is happening? So guys, I did a lot of this in the last class. Many of you might not understand it because if I repeat that again, this would be repetition for a lot of you. So for now, the only thing that you need to remember is this. I will do a separate revision at the end. P is 1 by 3. Assume this formula is true. I'll do a separate revision at the end, right? Assume I'm going to start afresh from here, right? This is the derivation we did in the last class. P is 1 by 3 into M by V into V RMS square. Assume that this is true for now. I will do the derivations later and then basically explain all of this in the end for those of you who missed the last class, right? For those of you who attended the last class, please click on yes. All people who attended the last class, please click on yes. I'm still waiting for you.
Ashwin sir, can you hear me? Sir, receive.
The yes button, if you click on the participants button, you will be able to see that button there. Okay.
Sir.
Okay,
Ashwin
I
sir,
think many of you are new students here. You have not attended the last class. Okay, so I'm going to just do this slowly. For those of you who have attended the last class, just bear with me for 5 to 10 minutes. Right, this is important for many people. So I'm going to go slightly slowly because this is the last part of the lesson on kinetic theory. Today the lesson will be done. There might be some numericals left, which I'll do in the next class. So I'm going to do slightly slowly. So don't worry. I'm going to again do all that we did in the last class. I'm going to go slowly, right? So let me now go one by one since I've laid this down very clearly, right? Okay, so it's the same definition. For those of you who know what the postulates of the kinetic theories or theory of gases is, click on yes. If you know what the postulates are, click on yes. Okay, more than 100 people have said they know the postulates. So that I'm not repeating. Okay, more than 150 people have said they know the postulates. So I'm not repeating that. So I'm assuming all that you need to know, many of you need to know, is just how to derive the expression that I just made. So if you want to know the derivation for the expression, this expression, if you don't know this, click on yes. Okay, I think many of you don't know this. So I'm now going to just very quickly do a very systematic derivation of this. Okay. All right. It's a very simple thing. Don't worry. In the next 10 minutes, you will understand it. So it's 3:50 now. By 4 o'clock, all of you will understand how this is derived. Okay. So now, once we know the postulates, correct? The first thing you need to know is how to define root mean square. Okay. So this is the first thing you need to understand. Now in mathematics, again, I'm repeating everything. So please don't keep putting on the chat. I'm going to repeat it again. This chap, many of you are new here. That's why we feel that this is happening again and again for you. There were some of the students who are on this chat who have done this. I'm anyway going to repeat this for all of you. Okay. So let me start from the beginning. Root mean square. So for root mean square, what is basically going to happen is we have studied in mathematics that if you have n numbers, x1, x2, x3 and xn. Okay, let's say we have n numbers. Okay, now in maths we have studied something called as an average or mean. Average or mean. The average or mean, if you define, if you know, is defined as x1 plus x2 plus x3. You add all the numbers and you divide it by the number of quantities, right? This all of you know. Click yes if you know this. Okay, very simple concept. All right, all of you know this. Now in maths, there is one more quantity. This is the regular mean. So we will call this the regular mean. Now in maths, there is one more type of average, which is defined as root square mean, which is what we are going to use in today's lesson. Correct? Root square mean for the same numbers is defined as root of x1 square plus x2 square till xn square divided by m. So it is just a simple definition. Okay. So let me now give you an example and make you do that example so that all of you understand this. Let's say we have three numbers, 4, 5 and 1. Okay, let's say we have three numbers, 4, 5 and 1. So three numbers. What will be the regular mean? I'm going to give you four options: 10, 10 by 3, 11, 11 by 3. What will be the regular mean? I'm going to do a poll. Please don't answer on chat. You'll see a poll. Answer this question, please. What will be the regular mean for these three numbers? No one should get this wrong. Some of you have answered this question wrong. This is very simple. Okay. I think many of you, 99% of you have got this right. In fact, to be precise, it's 94%. Right? I'm going to end the poll. So the regular mean is 4 plus 5 plus 1. And there are three numbers, 1, 2, and 3. So I'm going to do just this. This is the regular mean, the average, 10 by 3. Okay. So this is this, all of you know. Now, if you want to compute the root square mean for the same numbers, then that's my next question. What is the root square mean for the three numbers? Let me give you four options. A, 10 by 3. B, 14. C, 16. D, none of these. Okay. I'm going to launch a poll again. Answer the question. Based on what I just taught you, the poll will be visible in the bottom right hand corner. I can see some of you are making a silly mistake here in this problem. I'm going to relaunch the poll. Just wait a second. Just wait a second. In fact, I'm going to change the options a bit. Just give me a second. The question is the same. The options I'm going to change a bit. A is 10 by 3. B is 14. C is root 14. And D is 16. Okay. I'm going to relaunch the poll. Okay. Now answer this question for me. Most of you are getting this right. Okay, I'm going to give you 5 more seconds. Okay, I'm going to end the poll and show you what you have answered. So if you can see, more than 200 of you, almost exactly 200, 80% of you have got the correct answer, which is root 14. How do you get the root square mean? You do 1 square plus 4 square plus 5 square upon 3. But don't forget to take the under root. If you don't take the under root, you will end up taking B, which is the wrong answer. Because I've defined the root square mean as x1 square plus x2 square plus xn square by n ka under root. Don't forget the square root. So this is very clear. Click yes if this is clear. If you understood the difference between mean and root square, regular mean and root square mean. Okay. All of you have understood. I can see 190 people who have said yes. Okay. So this part is very clear to you. So this is the first thing you need to understand. So that complicated derivation that I did, this is the first thing you need to understand. Why is this important? The reason this is important, I'm going to scroll down. The reason this is important, in gases, we know that every gas, let's say there is a gas container. Okay. Now in this gas container, there are going to be many molecules that are moving. This is going to be moving. This is going to be moving. This is going to be moving. And we just said in kinetic theory, all of you said that you know the kinetic theory. Kinetic theory states that all gases move randomly, right? Which means this may have a different V1 velocity V1. This may have a velocity V2. This may have a velocity V3, correct? But if you want to associate one velocity with the gas, right? Because at the end of the day, the entire gas is in one container, which velocity will you use? So the velocity that we will use for a gas is the Vrms. What is Vrms? Vrms is take the individual velocities, V1 square plus V2 square plus V3 square, every molecule, take the velocities, square them and divide it by the number of molecules. This is the velocity we will use to measure the kinetic energy of a gas, right? That's why it is important. So another way of writing it is Vrms is nothing, ka square is V1 square plus V2 square plus V3 square plus Vn square upon n. So write down this expression. This is the definition of Vrms. RMS, right? Click if you understood, click yes if you understood this. Okay, I think all of you have understood this, right? There are a couple of you, just rewind with this video is also on YouTube. Just make sure you view that again. This is a very simple concept. All of you will understand this. Just remember that there are two types of means in maths. One is the regular mean. The second is the root square mean, right? The root square mean is what we call as RMS. Root mean square is also something we call it frequently. Okay. So I hope you have noted this down. Now, why is all of this important, right? All of this is important because the root mean square velocity gives us a good measure of the kinetic energy of a gas, right? Later on, we will understand. Again, I'm just stating it now. Don't ask me why, because I'm going to derive it later. Later on, you will understand that the root mean square velocity is a good measure of the kinetic energy of a gas, right? So we'll come to that in a while. So the first part of the class is understanding what root mean square is. I hope all of you understood what root mean square is. Remember the examples of 4, 5, 1 and remember this formula, right? I can also simplify it and write it as Vrms square is summation V square upon N. I can write it like this, right? Remember this. Okay, just remember this. Now let's move forward. Okay. Now what we need to understand here is we are now going to derive how, we are now going to find a quick derivation for the pressure of a gas and we will use kinetic theory to derive pressure. Right? That's what we will use. Don't worry if you have not been taught kinetic theory in class. I will do a quick revision at the end, and whenever I reference kinetic theory, I will explain that point. So now pressure of a gas. Now think of physics. In physics, what does pressure mean? Pressure means force upon area. Correct? This is what pressure means in physics. So even for a gas, pressure must mean force upon area. Now, if you have a surface, if you want to find out, so for a gas, what is the pressure? For a gas, the pressure is the pressure it exerts on a wall. Correct? So that is going to be the pressure by the gas. So that is what we are going to try and compute here. So now what we are going to do, we are going to assume that this is the basic assumption. We are going to assume that my gas is contained in a box. Okay, what are we going to assume? Assumption 1. So I'm going to write here. Assumption 1. Gas is enclosed in a box. And we will assume that this is a box of cubical shape and length L. So this is also L. This is also L. And this breadth is also L. This is my first assumption. Write down the first assumption. Okay. You're following me till now? Click yes if you're following me. All right. Everyone is following me. There are a couple of people, very simple. Just make sure you rewind and see this. Okay. Rewind on YouTube and see this again. Okay. All of you are following me. So this is the assumption. Now, if I want to find out the pressure on the gas, so we just saw that pressure is force upon area. So we have to now choose one area. We will choose this area, one wall of the gas, right? We will choose that wall. So what will happen is, let's say the room I'm sitting in, there are gas molecules hitting every wall, right? And those are the gas molecules that create a pressure on the gas. Now to compute this pressure, I need to know both the force and the area. Now what is the area of the wall? The area of the wall is, clearly, if you think of what is the area is L square. So the pressure is nothing but, as per this model, it is force upon L square. Correct? So now I know the area of that wall. All that I have to do to find out pressure of the gas is to find out the force on that wall. Okay, this is all that I need to do. So this is step 1. Step 1 is write pressure is force upon area and area is L square, hence pressure is force upon L square. Okay. Now let's come to the second step. Now to be able to compute pressure, I need to be able to compute force. I don't know what force is, correct? So let's now compute force. Now force F, we know, is delta P by delta T, rate of change of momentum. Which law of motion is this? First, second, or third? This is the third law of motion. Second law of motion, right? This is Newton's second law, which defines force. And in kinetic theory of gases, KTG says that gas molecules obey Newton's laws of motion. So this is what we are deriving from KTG, right? Kinetic theory of gases says this. That is one of the postulates. Okay. So this is the first postulate that's used. Now, what is delta P? Now to compute force, I need to compute delta P and delta T. I need to find out what is the change in momentum of a molecule and what is the time required for a molecule, right? So now if you take a wall, let's take a wall. Okay. Now there is a molecule that is coming here with speed. Let's assume take only the x direction, right? Let's assume that Vx is the speed with which it hits. Now it will rebound with Vx, correct? So first thing is, because KTG says all collisions are elastic, correct? This is what KTG says. That's one of the assumptions of KTG. This implies this is going to be the velocity, the momentum change. The change in momentum is mvx minus mvx is delta p. So delta p is 2 mvx in the x direction. This is delta px. Okay, understood this? Click yes if you have understood this. If you have understood this, click yes. Okay, for the 5-10 of you who have not understood this, think of this. This is the wall. It's hitting it with Vx and coming back with Vx. Now, because it's an elastic collision, what happens is it rebounds with the same velocity. The velocity will be the same. So going momentum is mvx, coming momentum is minus mvx because the direction changes. So the change in momentum is mvx minus mvx. So it is 2 mvx. Click if you have understood it. The 16 people who did not understand, click if you have understood it. Click yes. Okay, you have understood it. There are a couple of people who have not understood it. Just think about the momentum. You will understand this well. So we now know delta px is 2 mvx. Now this is the first part. So I now know the numerator. This is known, right? If I want to find out force, I also need the denominator, correct? How do I find out the denominator? Now delta t, the time taken for the collision, for 2 consecutive collisions. Now think of this. If this, I'm going to go down a bit. Think of the same wall. Now this is a cube, correct? Now what will happen is this molecule will first hit this, right? Let's say when it hits, time is t equal to 0. Now what will happen to the molecule? I'm going to draw its path in yellow. After it hits it, it will rebound, hit here and come back to the same wall after turning, getting hit from the previous wall. Now before the second hit, how much distance is it traveling? It's traveling L plus L because this cube is of length L. So the distance traveled is 2L. Is that correct? Click yes if you understand why the distance is 2L. Okay, most of you have understood this. So again, I'm repeating. So these are 2 walls. My molecule is hitting this. Now, after it hits this, it will travel L, then come back before it hits the second time. So the distance between 2 collisions on the molecule on the same wall is 2L, correct? The time, the distance taken, the time will be distance upon velocity. What is the velocity? It's Vx only always because the collisions are elastic. So the distance, the time delta t is distance upon speed, which is 2L upon Vx. So we know delta t also. If I go to come up, I know delta t from here This is delta T, and I know delta P. So if I now write down what is the expression for force in the x direction, force in the x direction is 2 mvx upon 2L upon Vx. So this 2 and 2 gets cancelled. This becomes mvx square by L. So if you remember, this was the derivation I did. So the force becomes mvx square by L. So this is the end of the second step. Again, to revise, the first step, pressure is force upon L square. In the second step, we say force is delta P upon delta T. We compute delta P and delta T separately and hence get mvx square upon L as the force. Delta P, we use the fact that mvx is the momentum, and delta T, we use the fact that 2L is the distance and Vx is the speed. Hence the time is 2L upon Vx. Just make sure you note this down. In the meanwhile, I'll check if there are any doubts. Okay, most doubts are technical, not technical doubts, but all of you are following. Good. Okay, so this is the second part. I'm sorry, I'm going a bit slowly, but after this, everyone will understand. I'll stretch the class a bit to make sure all the concepts are covered. This is a very important concept for both the JEE and the NEET, so and for your board examinations. So just make sure you understand this well. Okay, so we have understood the second part as well. Click yes if you have written this down. All right, I'm going to wait for 10 more seconds for you to write the summary, and I'm going to send the notes anyway, so don't bother writing so much. Just understand the concept very clearly. All right, I'm going to move on. Okay, so let me ask you a very quick question, just to make sure all of you are understanding it. In this derivation, what is the value of delta px? A mvx, B minus mvx, C 2 mvx. Let me run a poll to make sure all of you understood this. Okay. Some of you are clicking A, which means you're not paying close attention. All right, most of you have got this correct. Poll is visible. If you're not basically able to see the poll, go to the bottom right corner. You'll see a green notification. I see a doubt by Shreyas. Why did we take the distance as 2L? Shreyas again repeating. See, basically, I want to see what is the time between two consecutive collisions. If it does a collision now here, then it goes back L, then gets rebound by the other side and comes back here L. So L plus L. 2L is the distance between two consecutive collisions. Yes, Pritesh, it can also be in an angle, but that's why if you look here, I've only taken the x component. X component will obviously be in a straight line. So if it's an angle, I will treat the x component and y component separately, right? So that's why I've written Vx and delta Px. I hope you understood why I'm not taking that angle. Okay, so the correct answer is obviously C. 2 mvx is the value of delta Px, right? So now moving on, the third part of this derivation. So we just saw that delta Fx was mvx square by L. This is the force in the x direction. Okay. Now, remember that KTG says that motion of gas molecules is random. Correct? KTG says that motion of gas molecules is random. That basically means, you don't have to take the components. That's why I've assumed Vx, Vy, and Vz, right? Netra, for your doubt, what about collision of particle with other particles? one of the assumptions of KTG, which I wrote in the first slide, which I'll repeat again. One of the assumptions is we ignore the collisions with other particles. We assume that there are so small number of particles that we ignore collision of the particle with other particles between the two walls. We assume that they exert no force on each other. We assume it's negligible. Thank you, Vijay Lakshmi, for answering that. Right now, let's come back here. So KTG says that motion is random. This means for a velocity v, Vx, Vy, and Vz are all equally likely. So the same molecule V will have equal probability of having an X component, Y component, Z component. So we can say that, we can assume that Vx is equal to Vy equal to Vz. This is an assumption. Where does this assumption come from? This assumption comes from the fact that motion is random, and because motion is random, all motions are equally likely. Now, because Vx is Vy is Vz, we know that the total magnitude is root of x square, x ka magnitude plus y ka magnitude plus z ka magnitude. This we have studied in vectors. So now, because Vx is Vy is Vz, I can say that V is root of Vx square plus Vx square plus Vx square. Okay. So V square is 3Vx square. So the total velocity ka square we can basically assume is 3Vx square, and hence V square by 3 is Vx square. This we can assume. I can see some doubts here. Are the velocities in all angles same? They are not really same, but we can assume that they are same. Okay. Now, if we substitute this equation 1 here, I get the delta f, sorry, not delta fx, delta f, not delta f. I don't know why I wrote delta. F is mv square by 3L. And that's where I stopped. Okay. We assume that F is mv square by 3L. This is the force due to only one particle. So far, we have taken only one particle. Now, each particle will exert mv square by 3L. So, if there are n particles, the total force F will be पहले particle का mv1 square by 3L, the second particle's mv2 square by 3L, the third particle's mv3 square by 3L. Like this, there will be lots of particles. Every particle will give mv square by 3L force. This is what will happen. Why L? Just go back to the derivation, Abhishek. I'm going to show you here again. This L comes in the denominator, mvx square by L. Just go back to the derivation. All of you have been sleeping. Just see the derivation here. When we did this, fx was 2mvx upon 2L upon vx. Hence, mv square upon L will be the derivation. Right? Please pay attention in class. This L was there always. Okay? So, this is basically going to be the total force. Now, if I write this, F total is, I can take m by 3L common and write sigma v square. So this is basically the total velocity. Lakshman, no, all particles will not move with the same velocity. V1 can be separate, V2 can be separate, V3 can be separate. Okay. Now here is where I will make a small change. Now this I'm going to rewrite this as m by 3L. Numerator I'm going to multiply by the number of particles, and this sigma v square I'm going to divide by the number of particles. If you multiply and divide by the same number, nothing is going to change. It's going to remain the same. So this basically becomes m into n. Mass of one particle into number of particles is the total mass. So the force becomes the total mass m upon 3L. Now what is this? We just studied this some time back. What is this? This is Vrms. If you go back, I defined, that's why I started with the definition. This was Vrms. Remember this? Correct? So if that is Vrms, then I know that this is Vrms ka square. That's how we defined it. So F is M by 3L Vrms square. Okay? Yeah, sorry, I made a different thing. So limits of sigma, don't worry, 1 to n. Correct? Why 3L? Again, go back. V by 3 I did. Many of you are not paying attention, right? Jitin sir will answer those questions. Okay. So F is mv square by Vrms square by 3L. Now, what did we start off doing? We wanted to compute the pressure. Now, pressure, we said that was F by L square. So if I substitute the value of F, it is mv Rms square by 3L cube. Now, why 3L cube? If I do this by L square, L cube will remain. So this is what becomes the pressure. So this is nothing but 1 by 3. I'm just going to rewrite it as 1 by 3 into 1 by L cube into M into Vrms square. Now for a box of length L, what is L cube? L cube is the volume. So pressure now becomes mv Rms square divided by 3 times volume. This is the derivation that I said I will do. I hope you now totally understood what I tried to do here. Again, repeating this, m into n is total mass, because mass of one molecule multiplied by the number of molecules. This was Vrms, which is why I wrote this m into n as capital M, and sigma v square by m as Vrms square. Okay, so that n basically the one n got absorbed into m into n, the other n got absorbed into Vrms square. So that's basically how you derive this expression that I said I will tell you. It took some time, but maybe all of you now understood very clearly what is the expression for pressure. Click a yes if you understood. Okay, I can see more than 150, 160, 170, 180. Okay, now there's a doubt by Aman Bhaumik. Sir, why don't we consider the collision of the particle on another wall as consecutive collision? No. So Aman, think of it. We are trying to find the pressure on one wall. So if it collides on some other wall, that is not a pressure on this wall. No, it's a pressure on some other wall. I want to compute the pressure on the wall that I'm looking at. Okay, that's the reason why I'm doing that. Okay. All right. So now this is where we started off. Now let me start today's lesson. Okay. So this is what we said. P is mv Rms square by 3v. Now, if you now rearrange this, this basically becomes P is 1 by 3 into m by v into v Rms square. You can write this. Now, what is m by v? Mass upon volume. Mass upon volume is density. So I can write pressure is 1 by 3 rho Vrms square. This is the first expression for pressure, density, and Vrms. So please remember this. If I rearrange this, I can write it as Vrms square is 3p by density. Hence, Vrms is root of 3 times pressure by density. So many times in problems, when you're given just the pressure and the density, this is how you compute the value of the root mean square velocity. Note down this expression. And when you have written this, click on a yes. I'm going to clear all the yeses. So Vrms is directly proportional to, it looks like it. I'm not going to write that expression. Just remember this expression. Okay, let's now do a problem based on what we studied. Okay, based on just the formula that we studied. Okay, sorry. So remember this formula. So let's assume nitrogen at STP, standard temperature and pressure, has density 1.25 kilogram per meter cube. Okay, tell me what is Vrms for nitrogen. I'm giving you 4 options: 490 meters per second, B 980 meters per second, C 600 meters per second, and D 1560 meters per second. Okay, I'm going to give you a quick poll to answer this. Based on the formula that you just studied, just make sure you do this. For this, you need to know what the pressure at STP is. So that must have been taught to you. Just make sure you write that properly. Don't be in a hurry. Just compute it properly and answer. So Kiran, for pressure, I've given the fact that it's STP, standard temperature and pressure. So try to remember what is standard temperature and pressure. I'm going to give you 1 more minute to answer this. So don't be in a hurry, calculate it properly. The formula is known. I've given you the density. I've given you indirectly the pressure. You just need to do a calculation. I can see only 25 people have answered so far. Many of you are, I think, still calculating it. So if you're not getting poll, type the answer in the chat. Okay, I think many of you have given the answer. Not actually many of you, only 70, 75 of you. Many of you are being lazy and not doing calculations, hoping that sir will do the calculations. I am not going to do the calculation. I'm just going to tell you the correct answer. Okay. I'm going to end the poll in 10 seconds. Density is given here. Look at the question, Srishti. Okay, now around 120 of you have answered. There are still 200 of you who are not answering. I also know who is not answering. So next time you ask a doubt, I will not answer that if you don't attempt this. Okay, I'm going to end the poll. 5, 4, 3, 2, 1. So this is what you answered. 75% of you gave A as the answer. Let's see how to do this. A, in fact, is the correct answer. So well done, all of you. You can clap for yourself. There's a clap button there. You can clap for yourself. So the way to compute Vrms, many of you are having some problems here. So root 3p by rho. So root 3 times at STP, the pressure is 1 atmosphere. You have to remember this. Standard temperature and pressure is 1 atmosphere. And because it's 1 atmosphere, I'm going to not write 1 atmosphere as 1. I'm going to write it in SI units. Because the density is given in SI units. If you want the answer in meters per second, you have to convert everything to SI units. So this would basically be 10 raised to 5 Newton per meter square. That is pressure. And density is already given in 1 SI unit in SI units divided by 1.25 kilogram per meter cube. Don't use 760, don't use 1, use 10 raised to 5 because 1 atmosphere is 10 raised to 5 newtons per meter square, which is the SI unit. So always remember SI unit. If you want the answer in SI units, this should also be in SI units and this should also be in SI units. So just make sure you convert to SI units before computing it. And this gives the answer as 490 meters per second. It gives 492 or something. Many of you have, I think, have access to a calculator and did that. 490 is the correct answer. Okay, so well done all of you. Let's now move on. Yes, units always mess us up in physics. Just make sure you always use the correct units. Okay, let's now move on. So this is where we stopped. We said P is 1 by 3 rho V RMS square. Now, this is not the only way to do it. So we just see that P is 1 by 3 rho V RMS square. Correct? Let's go back to our older form. We basically said P is nothing but 1 by 3 m by v into V RMS square, because that's what is density. We can say PV is 1 by 3 mv RMS square. That's what we can say. Okay. Now, because we assume this is an ideal gas, for 1 mole of an ideal gas, we can say PV equal to 1 RT. Correct? This basically means if I take equation 1 and equation 2, I can basically say 1 by 3 mv RMS square is RT. Is that correct? Click yes if you understood how I did this. So I use the ideal gas equation. So I took the expression that I did, P equal to 1 by 3 rho V RMS square. I wrote rho is m by v because density is mass by volume. Then I took this velocity here. Then I wrote PV equal to 1 by 3 mv RMS square. And because ideal gas ke liye PV equal to 1 RT, because PV equal to nRT, I can basically say that 1 RT must be, LHS must be equal to the RHS must be equal to the RHS. So 1 by 3 mv RMS square is RT. So if I rearrange this a bit, I can say V RMS square is 3 RT by M. Now for 1 mole of a gas, M is nothing but M naught. So this V RMS is root of 3 RT by M naught. Here M naught is the molar mass of gas. So for instance, for hydrogen, M naught is 2 grams per mole. So we'll write it as 2, right? And grams, you should convert it into kilograms. R is the standard gas constant and T is the Kelvin temperature. Don't forget this. This is Kelvin temperature. So write down this expression. This expression tells us that V RMS square is proportional to T, or V RMS is proportional to root T. So if you increase the temperature, the root mean square velocity also increases, and the relationship is a root square relationship. Write this down. Give me a yes if you have written this down so that I can proceed. Yes, Avinash, if you have a question, you can put it. Okay, I'm not seeing a question from Avinash. I'm just going to move on. So this is the next part. So we studied two formulae. VRMS is root 3 RT by M naught, and we studied a formula. VRMS is root 3P by rho. Okay, so this is for 1 mole of molecules. Now we can also do this for 1 molecule, right? How do we do for 1 molecule? The way we do this, for 1 molecule, so this expression PV, 1 molecule means 1 by Na moles becomes R by Na into T, right? Why? Because 1 molecule is, Na molecules is 1 mole. So one molecule is 1 by Na moles. So I just did 1 by Na. So for one molecule, PV equal to R by Na into T. And for one molecule, 1 by 3 mv RMS square. M is the mass of one molecule, is R by Na into T. So the expression becomes very similar. The only change that happens is we basically get, instead of root 3 RT by M naught, for one molecule, we get root 3 R by NAT by M, where M is the mass of one molecule. This is nothing but root 3 KBT by M. So KB is R by Na, which is also called the Boltzmann constant. Right? So remember that and write this down. So Dhanush, I just gave H2 gas as an example. Suhas, yes, we can use this for other containers as well. Right? This is just a simplified description for one container. We can use this for other containers as well. Vaishnavi, small m is the mass of one molecule. I'm going to give you the value of Kb. I just want to make sure I give you the correct value. Just give me a second. So the value of Kb for you is 1.38 into 10 to the power minus 23 SI units, which is meter square, kilogram per second square, Kelvin. That's the value of Kb. Okay. So I hope you have written down all of this. If you have written this down, click a yes. Okay, got it. So that's value of Kb. So this is what we basically got, two expressions, 3R root 3 RT by M, root 3 P by rho, which is for the value of the root mean square velocity. Now we will come to translational kinetic energy for a molecule, right? Now we know that kinetic energy, what is the kinetic energy? Kinetic energy we know from physics is half mv square, right? That is basically kinetic energy. Yes, Na is the Avogadro's number. Thank you, Jitin, for answering that. Kinetic energy for any gas is half into mass into the velocity square. Now I can rewrite this as, sorry, half mass into n into v square upon n. I can rewrite it like this. Okay. Now we just know that this is the total mass m, and we know that this is the Vrms square. Correct? So kinetic energy is half m V RMS square. So if you want to find out basically the value of the kinetic energy of the gas, all you need to do is find out the root mean square velocity. You know the mass of the gas, half mv RMS square. So you know you don't need the individual velocities. You just compute V RMS square. Now, how do you compute V RMS square? There are two ways of computing. We just studied them. One way is root 3p by rho, and the other way is root 3 RT by M naught, right? You compute using any of these, that will basically give you the total kinetic energy for a gas. If you substitute root 3 RT by M, so if you can compute root 3 RT by M, that basically becomes half into M into 3 RT by M. So This m and m naught are the same. M gets cancelled. This basically becomes 3 RT by m for 1 mole of a gas. For 1 molecule, you have to divide it by Na. It becomes 3 kb. Sorry, 3 by 2 kb by m. 3 by 2 kb into T. So for 1 molecule, the contribution to the kinetic energy is 3 by 2 kbt. This is a very, very important expression that we will use. Suraj, n is basically total number of molecules. M is 1 molecule. This is the total number of molecules. Okay. This M is for 1 molecule. Since many of you are asking this M is for the total molecules, which is basically if we take 1 mole, we'll take the molar mass. R and T is basically, my bad, this M will not come. Yes, I made a mistake. Thank you for correcting me. R and T are the gas constant and the temperature. Yes, Prashant, I cancelled the M. Thanks for pointing it out, right? So it is for 1 mole, the kinetic energy for a single monoatomic gas is 3 RT by M, RT by 2. For 1 molecule, it is 3 by 2 kb into T. So remember this. I'm just going to write this in a separate slide as well. Kinetic energy for 1 single molecule or atom is 3 by 2 kb into T, right? This is something that will come frequently. Okay, so now that finishes the derivation of kinetic energy. I'm going to do 2 questions now just to keep you engaged and then move on. All right. Question 1. Okay, let's say, in fact, I have a question for you right here. If I increase only the pressure of a gas by 9 times, I make it 9 times, what will be the change in its RMS velocity? Answer A, it will become 9 times. B, it will become 3 times. C, 1 by 3 times. Or D, can't say. Okay, I'm going to launch a poll for you just to make sure you understood it. This is a tricky question. If I increase only the pressure of a gas 9 times, what will be the change in its Vrms? That's okay. You can answer in chat if you're not getting poll. Okay. You'll be very surprised at the answer today, or answer to this question. I'm now going to show you the answer. And many of you will be shocked. Many of you probably think you have given the right answer. I'm waiting for some responses. 190 of you have already answered. I'll wait for that to reach 200 and then I'll end the poll. Yes, 200 have answered. And I'm going to end the poll. So the results are mixed. Many of you have answered B also. Many of you have answered C also. However, let me tell you, all of you who answered B and C are wrong. The correct answer is actually D. I'll tell you why, right? This seems, I told you this is a very tricky question. This seems something which is easy, but not so easy. We have studied 2 formulae, right? There are 2 formulae that we studied. We studied Vrms is root 3 p by rho. Correct? That's the first thing you studied. And we also studied it's also equal to 3 RT by m naught. These are the two things we studied. Now remember, pressure and density are not independent. If you just change the pressure, what will basically happen is the density will also change. So numerator will also change and denominator will also change. So you can't really say pressure increases 3 times, density does not remain constant. Correct? So it's definitely not. So what all of you must have done is you must have seen that the numerator increases 9 times. So the denominator would be root 9 times. The VRMS would be root 9 times. That's not how you do it. So B is not the right answer. Remember that whenever you want to see the effect of a change, the VRMS actually depends only on temperature. Because if you look at this formula, R is a constant, molecular mass is a constant, everything is a constant, temperature is the only variable. So this is a key learning from this lesson, from this question. That's why I gave you this question. VRMS depends only, and write this down very well because a lot of questions are asked on this, on the temperature T. Changing the pressure does not change VRMS because pressure change ke saath density also changes, right? So both P and rho will adjust themselves to keep it constant. As far as you don't touch the temperature, that's why I said only the pressure, right? That was a hint for you. As far as I change only the temperature, the VRMS will change. If I change only the pressure, nothing will happen. If I change only the density, nothing will happen because pressure and density will adjust each other and ensure that the VRMS remains constant. VRMS depends only on the temperature T. Right? Please take note of this. This is a very, very important concept. Yes, Pritesh is correct. Density is directly proportional to pressure. So what will happen is if pressure increases 3 times, density will also increase 3 times. And as a consequence, numerator, denominator both will have 9 and they will get cancelled and VRMS remains constant. Okay. So this is a question which is frequently asked in competitive examinations. So just make sure that you take note of this. Shall we do one more question? Click on yes. If you want me to do one more question. Okay, let's do one more question. I hope you all have made note of this. So now I'm not going to give you a tricky question. I'm just going to give you a calculation question. Okay. VRMS for oxygen at room temperature is 500 meters per second. Okay. What will be VRMS for hydrogen at the same temperature? Again, I'm giving you options. 125 meters per second, 250 meters per second, 1000 meters per second, and D 2000 meters per second. Okay, let me launch a poll again for you. For those of you who can't see the poll, you can answer it in the chat. Try this. Okay, only 25 people have answered so far. Yes, I can see some answers on the chat. Suhas, I don't know why you're asking this question. Ke of two molecules is equal to universal gas constant. Just wait at the end of the class, I will answer that. Okay, I've seen that question. I didn't understand it. I'll just make sure I'll wait at the end of the class and answer it. Only 100 people have answered. I'm going to wait for that number to become 150. Okay. It's become 142. I'm waiting for that number to become 150. All right, we are at 150. Let's see what the answer is. So I think this time all of you got it right. The correct answer is 200 meters per second. Well done. So how do we do this? We know that Vrms is root 3 RT by M naught. If temperature is the same, if T is the same, we can say that Vrms is proportional to 1 by root M naught. So this means that V for O2 upon V for H2 is root of M of H2 upon M of O2, inverse proportional, and that will give you the answer as 2000 meters per second, correct? So because M of H2 is 2, M of O2 is 32, so there is a factor of 4 after doing under root, that will give you the answer as 2000, 500 into 4, 2000. The calculation is pretty simple. I'm not going to do this, okay? I'm going to do one last question because I think it's time for your chemistry class after this. I'm going to do one last question and then wrap up today's class. This is a tricky question, okay? Let's see if you get it. How many of you feel you're going to get it? Click yes. It's based on this. I am 100% sure many of you will not get this. Okay, many of you are very confident. So let me see. I'm going to see my screen. At least 100 people have said that they'll get it. Let's see. There's not a lot of calculations, but it's very conceptual. Okay. So suppose we take out all molecules, we remove all but one molecule in a gas container. Okay. So there is a container, it has only one molecule, okay, of a gas. Now my question is, now for the gas, let VA is the average velocity of the gas. And let Vrms equal to the root mean square velocity of the gas. Now my question to you is, there are three options. VA is greater than Vrms. VA is less than Vrms. VA is equal to Vrms. In fact, let me give you a fourth option also. Can't say. Okay. I'm going to start the new poll. Think of this. There's no calculation required here actually. You just have to think. And answer. "94 of you said that you will get this correct. Let me see. So remember that we have removed everything but only one molecule. So the container has only one molecule. Okay. Okay. I see 129, 130. I'm going to wait for a lot of responses. Okay. Think carefully. This is not a calculation question, but a conceptual question. Okay. Pranav, writing the same option 5 times does not mean that I'm going to see that a lot of times. I got your answer. Thank you for answering. Okay. I'm going to end the poll and show you how you have responded. Okay. The reason I call this a good question is, if you now look at the results, there are many people have answered different options. Okay. Let me first eliminate one option. The answer is not can't say. This is the wrong option. Okay. That I just put because just to see how many of you, 5 people have still chosen it, because you must have thought from the last class, that last question, that can't say could be an answer. Okay. Now, the mistake that people make here is, many people have studied formulae for average and RMS. You must have studied that V average is, I think it has some expression called root 8 RT by pi m, and Vrms is root 3 RT by m. That's what we just studied, right? And V most probable is root 2 RT by m, correct? These are some expressions you have studied. And you must have seen some graph which says that V average, V most probable is less than V average, less than V RMS. That's why most of you are clicking B. Let me tell you the correct answer in this case is C. VA is VRMS. Why? Now here, if you look at the question, I've told you that there is only one molecule, correct? Now, if a box has only one molecule, it has a velocity V. What is the definition of V average? V1 plus V2 plus V3 plus Vn upon n. That's the correct definition. Now, if there is only one molecule, n is 1 and V1 is V1, so V average is V1. Now, look at RMS. V RMS is root of V1 square upon 1. That is also V1. Correct? If there is only one molecule, both the root mean square and the average are the same. Hence, VA is equal to VRMS. So all the formulae of VA and VRMS are applicable only if there are multiple molecules. If there is only one molecule, VA, V most probable, VRMS, all of them are the same. So don't blindly remember the definitions, understand them conceptually. So for one molecule, average, root mean square, and most probable all will be the same. But for multiple molecules, if there are more than one molecule, they will all be different, right? So this is just a conceptual question that is usually asked to make sure you understand the theoretical formulations of VRMS and V average, right? Thank you for answering that. In fact, a lot of you got it wrong. 85 people still got it right. So that's very good. So I like the fact that some of you actually understood what is the trick here. All right, children, it's almost 5 o'clock. You have a chemistry class in 15 minutes. We went a bit slow today because many of you are attending the KTG class for the first time. Some of you have attended it previously. Now all of you are up to speed. In the next class, I'm not going to repeat all of this. This lesson is there on the Avanti Gurukul YouTube channel. For those of you who are missing it, just make sure that you view that. The next class is the last class on KTG. What I'm going to teach in the next class, I'll just go to write this down. Next class, we are going to learn first degrees of freedom. Make sure you study from the NCERT and come a bit. It will help a lot. Law of equipartition of energy. Then specific heats, mean free path. CP, CV, yes, how all this comes. This, you must have studied some of this in chemistry. Gamma. This we will study for different types of gases. That's the focus of our next class. Anyway, thank you for being patient. I know that some of you are attending this for the first class might have found it fast. Just view the videos on YouTube and you will get up to speed. I'm also now going to do a quick poll to collect feedback. You anyway have to be here because the next class is also happening here only. Just give that feedback and I'll end class. This feedback is also your attendance for this class. So just make sure that you register there. Hey, I'll answer that question in the next class. Just remember that and write it down because now you have a chemistry class. Nishikant sir will be getting ready. Or at the end of chemistry class, I'm still going to be there. I'll answer it there. Okay. VRMS will always be positive because it's a square root. It can never be negative. Jagadish, if there is only one molecule, you're right, density decreases and Vrms increases, right? But if there is only, usually that's a very theoretical case. It actually does not happen in reality, right? That's just a conceptual thing I asked you. It does never happens in reality. But your understanding is correct. What you said was right. Guys, you have like a 10-15 minute break. Nishikant sir will join exactly in the same link. So don't go away. If you want to have some water, stretch your legs, just make sure that you get some rest for 5-10 minutes. Do that and we will start.
Hello, Ashwin sir. Hello. Hello, Ashwin sir. Hello, Ashwin sir. Hello, Ashwin sir. Hello.